Hey kids, what's up? Mr. Murray here. I'm Mr. Murray's Mathland and tackling another classic optimization problem in calculus, and that is a distance from a point to a particular curve. So here's the one we're looking at today, and they're all kind of the same. Once you can do one, you can do them all. That is if you're using a calculator. If you're doing it by hand, you could be in for a tougher time depending. So it says find the point on this curve. F of x is equals 2 to the negative x plus 1. Notice there's that nice exponential decay with a horizontal asymptote of y equals 1. Just a little review there. Find the point on this curve that is closest to the point negative 5, 3 shown here. So you can probably eyeball that the closest point on this curve is probably somewhere right around in this ballpark, right? That's what you're trying to determine. So at least when you do use some calculus, when you do find that answer, you know you should be somewhere right around in here, maybe when x is about negative 2. A little bit more, a little bit less, maybe it's this point when x is about negative 2.1, maybe it's a little bit before that when x is about negative 1.9, but should be in there somewhere. So as always, the big problem with all optimization is that you have to sometimes do a little thinking, right? And you need a function that you can actually use some calculus on. So we're trying to find when this is closest, the point that is closest to negative 5, 3. So it doesn't flat out tell you, maximum volume, minimum area, minimum surface area, something like that. So just think about what that means. Closest means the minimum distance, right? So we're talking about a distance from this point that we have, which is negative 5, 3, to some point on this curve. So and right now I'll just call that point xy, but I want to minimize the distance between those two. Okay, so if you remember your distance formula, we're going to be using that. If you don't remember your distance formula, remember it's all based off Pythagorean theorem, right? And it's just a right triangle where you're finding the hypotenuse, a squared plus b squared equals c squared. So c is equal to the square root of a squared plus b squared, or our distance is the big square root of, and a is the difference between the x's, right? x2 minus x1 squared plus the difference in the y values. If you just flat out remember the formula, that's great, but if you don't, maybe you can recreate it in your head. There we go. So for this particular problem, what are our 2 points? Now here's where you want to get a little bit better here. This is where we usually use some kind of secondary condition so that we aren't using 2 variables, right? So our first difference between our x values, that seems pretty good. X minus negative 5 or x plus 5 squared. Or you can do negative 5 minus x. Remember, the order doesn't matter because you're taking the difference and squaring it. And your difference in your y values. So instead of calling this y, remember y is just f of x, right? And what is y equal to on this problem? 2 to the negative x plus 1. So I'm literally going to use the function because that's in terms of x. 2 to the negative x plus 1. And then you are subtracting this y value of 3, right? That is y minus y. Y minus 3, and y is really just this. And that's the thing that happens on all these distance point, to a curve problems, is you use the function name in place of y, and there we go. Okay, so if you're like me, that is bugging you that you want to do that one little subtraction step. So x plus 5 squared plus 2 to the negative x, and 1 minus 3 is negative 2 squared. Okay, so here we go as always. Now what do we want to do? We want to find the derivative. Yeesh. Well, it's not terrible, a big chain rule kind of thing, but 2 to the negative x is in there. You got to remember your exponential rules. That'll be ln of 2 times 2 to the negative x times negative 1, blah, blah, blah. So we're going to use our calculator for this, but just keep in mind, right, the calculator is great, but you have to represent whatever you're going to do on paper. So what is it that I was going to do if I was doing it by hand? I would be finding the derivative, and then I'd be setting it equal to 0. So that's all I'm going to write. If that's d, then d prime equals 0 for what x value? There we go. I'm showing the AP graders. This is the equation I'm solving, and I'm showing the solution right along with it. Now I'm going to use the calculator to get it. So I'm bringing up the calculator. I'm going to go to the graphing menu here, the inventory, and I'm going to put my original function in there. So big square root of, now another fun thing here though, if you were doing this by hand, is to keep in mind that you could really just take away the big square root sign in these problems, because, I mean, when I say take that away, I mean just in terms of trying to find the critical number, because if you minimize the inside of it, you'll be minimizing the square root itself. So you could just do that, but we're using the calculator here, so this is going to be 2 to the negative x minus 2. Make sure you type everything correctly. Minus 2 squared. We didn't miss any exponents or anything there. And then if you remember here, or if you haven't seen this before, I'm going to graph the derivative. I don't know the derivative, but I can use the calculator to graph it. And that's that math 8, the end derivative feature there. So you can scroll down or just type 8. That brings that back. The first variable is what variable are you differentiating with respect to, and that's always x. This is what are you taking the derivative of, and that would be that equation that's in y1. So you can either retype that, or remember there's a shortcut where you can just use the name y1. Alpha trace brings up the F4 menu. There's y1. And the last one is, well, what x value do you want the derivative at? I don't know. I want to see f prime of x. I want to see the whole function derivative for all values of x, so you just type x. So x, y1, and x. And lastly, if you're like me, maybe you don't even want to see the original function graph. You just want to see the derivative and see where that equals 0. So I'm going to shut that off. I'm going to unhighlight that. If you want to see it again, it's still there. Just re-highlight the equal sign. Hit enter. Okay, and before I do, I'm going to usually change my windows. Usually these, you have a good idea of what's going on. In fact, in this problem, look at, I really know it's in this ballpark. But at the very least, I know it's somewhere between -5 and 0, right? It's not going to be over here or over here. So I'm going to change my x minimum from -5 to 0. The y min and max, I could leave. I don't know. If I need to change them, I will. But let's hit graph. Let's see what we see. Hey, look at that. And keep in mind your scale, that just crossed the x-axis, right? That went from below to above. So that is going f prime from negative to positive, or d prime is going from negative to positive for x equals, and it's somewhere between -1 and -2 and very close to -2, as we kind of knew it should be. So let's get that 0. Second trace 0. Left bound, you could hit enter right now. You're to the left of it. Right bound, you can scroll to the right of it, or just type -1 or something, anything to the right of it. Give it that right bound. For guess, just hit enter. If there's only one 0 in the window that you've set up, that'll go right to it. So that'll be for x is approximately -1.758. And if you want to use more decimals, it's up to you for right now. But yeah, let's verify on paper that that is in fact yielding a minimum, which is what we're trying to do. We're trying to convince, right? So This is what we would do by hand. If we didn't have a calculator showing it to us, we would be checking using the first derivative test. Does d prime change signs? And I don't have to test. I'm looking right at the graph. I see that before it, d prime is negative, which tells me, think about that. That means that d, the distance between these 2 points, is decreasing as you approach negative 1.758. Think about that. Being on this curve, as x approaches that, the distance between here and that given point is decreasing until you get to this spot. And then after that spot, you can see the derivative graph goes to above the x-axis, so d prime is positive, meaning that distance is now increasing, which should make sense because you get past that spot and the distance from here to the curve starts to increase, and it's just going to get bigger after that. So this is the minimum you're looking for. It's a relative minimum, but it's also the absolute minimum in this case. And so now let's just answer the question. It said find the point on the function. So keep in mind, sometimes it'll ask for what is the distance. In this case, it just wants that point. So I want this point, xy. And this brings up another good point, that x value of negative 1.758 is rounded. And I'm going to plug that into my function to get the y value. But if you plug in a rounded value to get another value, that new value might not be quite as accurate as you want it to be. So frequently, this sort of thing, we might use the calculator to store those decimals, or at least just write them on paper, go beyond 3 places, type in more, all the decimals it's showing you. But if you use your calculator, you can be pretty handy with this. The answer brings back the last thing the calculator calculated, which was that 0. So there you can see it goes beyond even the decimals it was showing on the graphing screen. And now I'm going to store that because I'm going to use it. So I'm going to store that in, you can store wherever you want, but I'm going to store it in alpha A. And now whenever I want to use that decimal, if this was like a 3-part problem and I had to do multiple things, I could just use this A button on my calculator, alpha A, whenever I want to bring that decimal back. Okay, so in this case, I want to know, I just need the y coordinate that's going along with it, and that would be on this function, which is 2 to the negative x plus 1. So that's what you're plugging into this. Not plugging into here. That will give you what is that minimum distance you're looking for, which is sometimes what's asked. But in this case, it just wants the point, x comma y, using 2 to the negative x plus 1. So f of negative 1.758, and I can write 3 decimals, even though on my calculator I'm going to use that a value. So that's going to be 2 raised to the negative, and here's where I'm going to use that a value, so 2 to the negative a, which is really positive 1.758, etc., plus 1. And this way, I know I'm getting the most accurate answer, and that would be about 4.383, and now I can round to 3 places if you like, or truncate, as long as you're accurate to 3 places. So, answer with a sentence here. The closest point is negative 1.758, comma 4.383. And there we go. So hopefully we got a little refresher on a lot of stuff in here, distance formula, how to set up a general optimization problem, and even how to use the calculator and some of the other little quirks with it. So if you got any questions, let me know. Otherwise, keep working hard and hang in there, kids.